Manikandan sir. Manikandan sir.
Yeah, hi.
Sir, good evening. Good evening, sir. Hearty welcome for to this FDP, sir. Sir, can we start, sir? Can we start the session?
Yeah, sure.
Yes, sir. Participants, welcome back to the session 8 of this FDP. Today, we have Mr. K. Manikandan. He's an automotive engineer. Mr. K. Manikandan is a skilled automotive engineer with over 6.5 years of experience in the automotive domain and embedded system development. He has a solid foundation in software requirement analysis, design validation, integration testing, and embedded software development. Known for his teamwork and communication skills, he thrives in fast-paced environments that challenge him to enhance his technical experience. Mr. K. Manikandan finished his Bachelor's of Engineering from Sri Ramakrishna Engineering College in the year 2018. He joined Clancore Microsystems as embedded software developer. He worked with RTOS, ATAS-based applications for devices like billing systems and token issuers. He worked in the platform of ARM7, PIC32MX, ESP32, and other platforms like Arduino and Raspberry Pi. He developed IoT solutions and smart mobile printer applications. Later, he joined as senior automotive test engineer in L&T Technology Services. While in L&T Technology Services, he worked with automotive powertrain ECU software in the AutoSAR domain. He's very proficient in tools like Vector Canoe and DaVinci configurator for testing and requirement-based test case design. He has got expertise in project management tools like Polarion and Jira. Currently, he's working in Tata Elxsi. He's working as senior automotive test engineer in Tata Elxsi. He has done various projects with RD TS Gen, automotive powertrain ECU software. He has developed IoT-based industrial monitoring and control systems using CC3200. He has got several certifications and skill sets, proficient in AutoSAR, UDS, Python, Embedded C, and HIL testing systems. Mr. Manikandan has a strong passion for AutoSAR software testing, Python automation, and IoT applications. His work reflects his dedication to innovation in automotive engineering and embedded system development. Sir, the floor is open to you. You can start your session. Hello.
Yeah, thank you so much. Yeah. So thank you so much for this opportunity. Okay, let's share my screen. Please let me know once my screen is visible.
It is visible, sir.
Yeah, okay, thank you. So today I will take the session for that cloud-based artificial intelligence framework for battery management system. These are currently is glowing on this feature actually for entire EV vehicles. So agenda of this session is we have few topics. First one is lithium and batteries. Next one is battery management system. That is the BMS. After that artificial intelligence for the AI features. So then in AI feature, how we are using the battery management system. So that concept. So and finally, I will show a few sample application for how we can use AI concept, that different features. So first one is lithium batteries. So we have like different type of batteries. One is like lithium ion batteries. Next one is like a lead acid battery. But mostly prefer for the lithium ion batteries. Okay, because we get different type of future will be there. So first one is like weight of the battery. So next one is number of battery we are using, right? So that one. So especially electric vehicle for this topic I'm speaking. Okay. So here lithium ion battery, right? So normally batteries matters like anode and cathode with a separator. So electrolyte based on that. So electrolyte will be different type of batteries will be based on that. So normally positive and negative two current collectors will be there. Okay. So here electrolyte carries positively change the lithium ions. So this concept. Why we are using like this battery is weight is less. Also we can use multiple battery with current rating. So entire EV vehicles normally we are using like mostly in lithium ion batteries for preferred on that. So but some other applications also we are using. So based on the lithium ion batteries, so normally mobiles, laptop, also electric vehicle. So these three features normally using on that for the applications. So next one is like BMS system, right? In the entire AV vehicles, why we are like prefer the BMS system? Why we need the BMS? So that is one. So mainly like we have like solid 4 points is there. First one is like detect the unsafe operation condition and respond. Okay. So because while using like a lithium battery, right? So mostly we get many accident in last 2 years to be back. So it's like a battery over voltage or some temperature be heating or battery be blast. So our overcharging we are getting, right. So that is a like a unsafe operation we get some accident. So in BMS system we are using to like predict the when this accident happen, right. So we need to have the safe mode. So that we are prefer on that. So next one is like protect the cells of the battery from damage in numbers and failure cases. Okay. So that is the second point. Um, that one is like prolongs the life of battery. So like every battery has different lives. Okay. So example, particular battery around like 1,000 to 1,500 life cycle be there. We need to charge and discharge that one. Okay. So normally we not observe that particular recycling, like how much time are we charged and battery life, that scenario. So in BMS, we can consider that this one also like we can monitor. So upcoming slides, I will explain the in-depth of the BMS system. So next one is maintain the battery in a state. So normally battery have the different stages there, like charging state and how the health issue, like
So you're not audible, sir.
Manikandan, sir.
hello. Hello.
Now it's fine,
Hello.
sir.
Now I am audible now, right?
Yes, sir, it's audible, sir.
Okay. So actually, which slide actually that audio is not detect, not happen?
Fourth one, sir.
Okay, this one.
Yeah, this one, sir.
Okay, so thank you. So in starting, the audio is not available, not happen now.
So from this slide only, we were not able to hear, sir.
Okay, okay, thank you, ma'am. So I will start with again for this slide. So like why we need the BMS system? BMS it's like a battery management system. So we have like four dependency with the battery management system. So like whenever we are using that lithium battery, right, battery pack. So we are in EV vehicle. Last 2 years we are getting like some of you accident also will be there. Okay, because overcharging. Suppose battery be overheat after that in electric vehicles. Example, EV bikes and EV cars also. So these 4 points dependency for the BMS system. First one is like detect the unsafe operation condition and the respond. So this option we can monitor the entire battery life cycles and how is the overheating or temperature analyzing that concept. Next one is like protect the cell of the battery from damage to the failure cases. So that means like a particular cell, BMS system based on the every cell we are monitoring. Suppose if you not so heating temperature values or it's not update the charging or not, so that they're able to detect on the sensors. Next one is like prolong the life of the battery. So every battery have the around 1000 to 1500 charging life cycles, like charging and discharging that one. So so we need to consider that in BMS based on that we can easily monitor that. So every battery, so how much time it be charging discharging time, that life cycle also we can able to monitor. So next one is like maintain the battery in a state. So we have like battery state, right? One is like a empty state, next one is charging full. Suppose it will drain it or not. So that type of status also we can get. So that is the main major dependency with the BMS system. These 4 points. So next one is like BMS. It's like a battery management system. So on electric vehicle, generally contain of following the major component there. One is like electric motor and motor control and the traction of the battery and the battery management system, wiring system. Also like vehicle body with the frame. Okay. But the battery management system is one of the most important component because example particular electric vehicle, right, is 40% of price will be cost of that only for that battery pack. Okay, for the electric vehicles. So like suppose we are buying the electric vehicle, particular battery we are not maintaining properly. So any damage is there, that is the cost of the 40% of the vehicle. So again need to buy. So that is the one major issue previously we are have. So next one is the lithium and cell operating voltage, current, temperature, and must be maintained with a safe operation area. So BMS mainly it will handle for that only for the safe state. So safe condition we are checking. So lithium and ion cells, it's like a particular battery pack. So one battery pack around like 80 to 100 cells will be there. So all the cells is monitoring by the voltage, current rating, temperature. So this major we are getting the sensors based we are monitoring. So that is a safe operation area. So that feature. So to maintain the safe operation of the batteries, they require the productive device. It's built to each pack is called the battery management system. So this is the block diagram of the BMS system. So this is a battery management system. It's like in center point will be like a current, voltage, temperature. These are 3 types of sensors. So every cells we are monitoring the battery current value, amperes, and battery voltage level, how much battery will be take after the temperature range. So also like a data acquisition. So data acquisition is here like we are predicted previously mentioned the particular range. Like every battery with a particular current and like minimum maximum voltage rating and current value, also temperature. So this we are using get the sensors based on the data. We are analyzing. After that, we can send the data to state destination. So that means we are analyzing the value and send the data. Example, user interface, right? User interface is like in electric vehicle, we get the dashboard, right? So in display, we are checking the battery level. So how much battery we trained and how much we can charge. So that scenario indication we get from the user interface. Also like safety protection, that is like electric control will be there. So example, in vehicle we are key, right? Key on off condition means automatically is disable the safety protection of that. So electric control we can on off that condition. So in below mention the communication and the thermal management. So thermal management means like this battery pack have the sensors like LM35 related temperature sensor is there. So that sensor we can get the temperature value. It's like a minimum maximum temperature rating is there. Suppose it be battery we have like over charging is happening, means some heat will be there. Okay. So based on thermal value, we have separate different type of cooling system. So we are using like currently in a 2 type of cooling system. One is like airflow cooling system. Next one is liquid cooling system. Okay. So in normal basic vehicles, normally using air cooling system. Particular fan is there. So based on the temperature range, we are enabling the fan. Then airflow will be detected. So we are maintaining the battery temperature value. So in like in luxury vehicle or a higher value vehicle, higher end vehicles, we are using the liquid cooling system. Okay, so that one means like normally equally maintain the temperature range. So when because this thermal management, we are considering that we are in safe state for the temperature value. So if any battery is over voltage or detector means we automatically detected. So this is a block diagram for the overview. So next one is like interface BMS with the batteries. So BMS system, it's like a separate one hardware, okay, electronic hardware. So this hardware have like MOSFET with a different type of sensors is there. So based on the cells, we are like design the circuit. It's like a 10 ampere and voltage rating. Example 12 volt battery or 440 voltage battery. So based on the battery pack, we are using the call it the cells. Example 80 different of cells. So minimum 80 cells we are using for the lithium ion cells. So every cells is connected with a negative and positive, right? So every cells have, example, 80 cells have 80 different of sensors. Okay. So in battery pack, we get different of 80 single line wire connection is there. So that pack is connected with all the cells. So automatically, so every cells we are monitoring the voltage rating, also like it's a charging, discharging value, also temperature value. So this three value normally detected. So this is the battery management system. So it's interconnect with the cooling system also. So cooling system, we have two different is there. One is like air cooling system. It's like a fan. So next one is like a liquid cooling system. So we are flow the liquid of that inside of batteries. We are cooling like maintain the temperature range. Next one is like this electric part, like conductor control pack measurement. So this two end we are kind of positive and negative. So mostly battery pack is like a DC supply we are using. So this is a positive and negative connector. So this is one connecting with that instead of the ECO. So next one is like a coast application control computer. So BMS have different communications. So like upcoming slides, I will show the different communication side. So in the right hand side, one image is there. So this is an electric vehicle. So in the bottom side, we have the this square type of battery is there. So we get different of cells. In above cells, we are using a battery pack. So this every cells we have the different type of ICs. Okay. So this is a BMS system basic concept. So we have different type of ECU with connect with the sensors. We are detect the value and send the particular sensor to the dashboard. So we are getting the status of the battery management system values. So this is the connection of the battery pack. So normally like lithium battery we already know, but how it is instead of connection is there is like example serial connection or parallel connection, and every have the battery pack, right? So battery pack how is arrangement is there? So this is a battery pack example. This battery pack sample it's managed like arrangement of 80 cells is there. So it's connecting a positive and a negative scenario. So 2N is connected with like a series connection. Okay. So it's like a square type of battery pack. So we are using like based on the vehicles and number of the cells is different type of connection we are updating. Like example series connections. Also communication, right? This yellow box, right? This is a COM. So this is a communication value. So this is a sensor lead actually. So we have like a different type of communication. So here you see the RS485. This is the old one, older version, the battery type communication. So normally three-wire system we are using like positive, negative, and ground the connections. So next one is like function of a BMS. So below the few different of functions. So like we are preferred to the BMS, right? So we can use the different of functions for the clarity. So first one is cell voltage monitoring. The importance of the individual cell voltage monitoring. So that means example we have like around 80 every pack have different of counts. So example sample we have like one battery pack is around 80 cells. Suppose we not monitoring the 80 cells, okay, just checking the overall cells voltage. That means some cells charging this life cycle is be gone means it will blast. We have it happen the temperature value be heat and some issue be happen. So like we have the different of sensing value for the every cells. So we are monitoring the individual cells for that one. So that means around 80 cells. Suppose the 2 cells is not working, some charging is not detected means automatically indicate the BMS system. we can get from the dashboard the indication for that which type of issue there. So these are different categories. So cell voltage issue or SOC or SOH issue. So we can easily identify that based on the symbols. So in dashboard. So first one is like that's why we are using like checking that individual cells for the sensing the value. Next one is state of the charge estimation. So discuss the method of the estimation remaining battery capacity. So it's like a example 80 pack 80 cells pack, it's like a particular voltage range around like a 440 voltage or a 650 voltage. So based on the vehicle, it'll be battery voltage we are predict actually. So example, so state of charge means it's a battery life is like drained or not, or like minimum voltage or maximum voltage, or which state battery is full. So that status, right? So this is a state actually we are monitoring. So that part we are considering that BMS system. So next one is state of the health estimation. So BMS has the overall health of the battery pack. So health is like a temperature range, also like a current life cycle. So how much of current will be taken? So because lithium and battery, mainly we are choosing like a current range. So it's a milliamperes higher value. So voltage normally concern the minimum and maximum voltage range. Example, minimum means 2.5 voltage or maximum is 3.3 voltage. So normally we are charging, right? So we are health means every battery, so minimum is 2.5 voltage. So less than 2.5 means that battery, so that is not used because that it's like a death condition of the battery. Okay. So BMS mainly concern that we are maintain the proper range. Example, suppose battery will be drained means minimum 2.5 voltage. So below is not taken, say cut off the voltage. So also like maximum voltage, suppose 100 range, right? So 100 voltage range, 100% range will be come to around 3 to 4 hours, okay, for the charging time. Suppose we are giving it 6 hours, that means so automatically after 100%, right, automatically monitor the percent of the range after the cut off the voltage. So it's like a relay concept will be there inside of a BMS system. So automatically cut off means so better in safe state. Okay, so that health state we are monitoring on that and predict the data. Next one is temperature monitoring and management. So like every BMS system have the particular sensors, temperature sensors. So but temperature sensor we are using only one sensor is because the battery backup is fully covered. So based on the temperature range, we are predicted that minimum and maximum temperature value. So normally maintaining the range. Suppose it be going to maximum, we are indication after that we are controlling the um, temperature value. So that means we are using a particular that temperature range is increased. We are controlling the particular cooling system. So then we can balance the temperature range. So that is a management concept. Next one is cell balancing. The process of the equation cell voltage to improve the battery life. So it's like how much time will be we are charging, right? That number of battery life cycles, like charging and discharging time. So that one also we are monitoring. So that means example like 1,000 times we need to recycling concept will be there around 50 or 80% is done. This indication also there, like we need to service the battery. So that indication also newly added for the BMS system. So that is a different type of features in BMS system. So in BMS system, right, we have like different type of features. First one is we monitoring battery parameters. So monitoring the parameters for BMS means like below status we can get for the sensor. We have different type of sensors. Example, voltage sensors. It's like indicate the cells of the total voltage, battery combined voltage, and maximum and minimum cells of the voltage. So this is a different type of category we can get in based on a single sensor. Next one is the temperature. So normally we are entering the display is average the cell temperatures and coolant intake or output temperatures is mentioned. Because we have one relay, so relay is operating based on the temperature sensors only. It's like a normal value or maximum value. It's temperature is going to maximum value, so automatically enable the coolant system. So that point is mentioned on the second one. So that point is like the state of the charge of the cell. So like while giving the charging, right, we are putting the charger is indicating that like that battery charging state or uncharging or any issue will be detected. So it's like a OBD concept, onboard diagnostic concept. So that type of data we easily identify that and we can send the data to the ECU. So we can get the status on the dashboard. So next one is like the cell status of the health. Show the remains of the battery capacity of the percentage of the original capacity. Because we are in a particular sensors, right? Normally it's not properly, like without BMS system, it's not detected the particular voltage range. If we example in a display, it's showing around 40 to 60%, but battery is not charged that much of range. Okay, so we are using BMS system means we are like monitoring the every cells. So like the sensor value is accurately data, we can get the accurate values. So that is the one point of health. So next one, the cell of the status of power. So the amount of the power available, the certain duration, gives the current usage, temperature, and user factor. So this is the overall power rating. Initially we are seeing the voltage range and current range and they separate that. So, but finally we are at the power like watts. So because while choosing the battery, right, based on the different of vehicles, so mainly we are concerned the how much watts will be there, the power. So based on that, we are like calculating the number of cells and backup battery backup size and type of the lithium battery cells. So that is a major point. So next one is like managing thermal temperature. So temperature is the biggest factor affecting the battery because while accident, right, we happen the like a battery flash or temperature happen. So that is the previously we are getting some issue. So now that is a result based on the BMS system. So this is the battery thermal management system. Keep on the eye on the control of the temperature of the battery. This system can either the positive, passive, and active as the cooling systems. So that is the major point. Like it's like a non-corrosive liquid and the air. So these 2 points we are using that for the cooling systems. So next one is like making key calculations because this battery, right? So battery management system is mainly based on that voltage and current rating, that and watts, how much will be take the time and how much we can use utilities. So that type of concept. Because so few years back we are using not BMS concept. Just we are use the charge the battery and we are using the voltage like voltage and the train the usage actually. But now we can easily predict. So based on this type of calculations, because example 100% will be there the battery, we can calculate around 100 kilometer, 100 to 120 kilometer we can easily use. Suppose battery in stage is like 60%, we can use like eco vehicle mode. We have the different life of modes also there, sports mode and eco type mode. So based on the utilities, automatically change the modes. So based on that, we can consider that how much kilometer we can use. So that if based on the calculation, this is calculated based on that. So this calculations, example, energy of the kilowatts based on the hours, how much hours we can use that the battery. So that one. Next one, the internal impedance of the battery measurement cell open circuit voltage. It's like open circuit and short circuit is there. It's like vehicle is not in a running mode. So how much will be minimum voltage will be taken. So while running mode short circuit that concept. So any issue will happen, we easily identify that particular sensors. So that is a key value calculations will be there. So next one is major feature like this one, like internal and external communication. So based on the different vehicles, we are seeing different communications. So first one is like a serial communication. It's like wired communication. So but serial communication means like some delay is there. We are not getting the that much of fast because lower end vehicle we are not normally using that serial communication. Is example RS 432. So RS 232, that concept, that type of cables we are using. So next one is CAN bus communication. So normally in automotive industry, normally using the CAN network, CAN protocol. It's like very fast and we are getting the very accurate value is there. So normally we are using the CAN bus that protocol. Next one is DC communication. It's like a similar of same serial bus communication. So that one. Last one is variety of wireless communication. So like previously, which wired vehicle, right? So normally in lower end vehicle, normally using CAN bus communication. But in higher end vehicle, it's fully like full EV with ADAS concept, right? Like advanced driving concept. So that type of vehicles, we are using wireless communications. It's like a cell phone and a cloud server based we are using. So this all the battery status, BMS status, we are send the data to wireless communication to the particular cloud. So So cloud-based particular website we have like a particular URL, we can send the data. So we can easily we can get the data from that in dashboard. Also like in mobile we have particular EV vehicle apps. So that app you can see all the data like whichever vehicle we have the particular data, right? Like off state, on state, and the battery and auto drive mode. So all the status we can easily identify that, monitor, and able to control also. So on off key. So that type of option will present the like luxury vehicles. So that is the like fourth point. So this is the overall advantage of the BMS system. Example like we have the median temperature, mean current voltage, and also medium value. So medium temperature, voltage, current, and various of current and variant of temperature, also voltage. So normally standard division also there, because every vehicle we have like particular we are following the particular ISO standards for the power factor values with the power conditions. So with the division, current, and voltage, temperature. So while developing the BMS system, right? So example, one new organization is that newly developing the battery backup of that, we need to follow the particular standards and we need to get the approval. So then only we can use approval. After approval only we can use the particular EV vehicles based on the different of BMS systems. So if you have any doubts on BMS system, any questions? Okay, it's fine, right? Hello.
Sir, you can continue, sir.
Okay, fine. Thank you. So next one is like AI, so artificial intelligence. So artificial intelligence is a field of the science concerned with the build computers and a machine that can be the reason of the learning and act of the such of the way that would normally require the human intelligence. So also like AI is like a broad field that in terms of like many different disciplines, including computer science, data analytics, and statistics, and hardware and software engineering. So it's this AI feature we normally using like neuroscience, also like electric vehicle. It's like ADAS concept that one also. So AI like we have like there is a particular so new advanced system. So normally previously we are using that particular tools or automation concept we are initially used it on that. So now this feature will be newly added from the EV side, electric vehicle side. So benefits of the AI. So first one is like automation. So automation means like we have different of scenarios there for the work culture. Example like in embedded side or automotive side, we get like we are developing the particular softwares and we need to testing the particular software is properly working on before the production. So that time like we need to use like multiple members for that, for the human dependencies there. We need to test around 1,000 test cases with a proper before production. We need to particular delay like we need to use, but automation, right? So that means we have like different type of condition is there in AI. One is like machine learning, another one is deep learning concept. So we need to predict the data and we can analyze the value. So get input from that directly with the sensors and the real-time hardwares, also particular data sheets. So after that, we can compare with the data sheets with the live data, and we are get a good result on that. So that is for automation. We have developed a few tools for that one. So that is the first point. Next one is reduce the like human error. It's like suppose in one new technology we are just developing that time. We are checking that R&D development, right? Research and development, that concept. So that is for department. Normally using like particular new features. we are calculating the data and we are predict the value. Example, battery means we need to monitor that how much time we take the charging time and reduce and how much time it be trained. So that about testing we are doing. So while developing the battery pack, so that time we are using that AI means it be automatically sense like perfect data and predict the correct value. So that sensing and the proper values we are getting using the help of the AI actually. So next is fast and accurate. So normally human we are using right like uh, human it's working with a particular time period. It likely be take more time. Also like data we not show the particular accurately because we are checking that every hours. So that will be there. But while using the AI, we have the sensing right sensor the sensing the sensors. If we take the every seconds, if we take the data based on the data set we are analyzing. So also predict the particular data is based on the algorithm. So like different feature have different algorithm. So based on the algorithms, we are using that particular features applications. So that means we can get the fast and accurate the applications for the benefits. So that one. Next one, calculate the research and development. So while developing the new features with the concept, so that time we can like different type of open source AI is there, like different type of websites we can easily get the data. Also like so normally Google we are checking the particular question right. That means we need to find the every website we need to go and we need to check. But instead of AI we have like different website is there. So that website if the single question it be get the mostly accurate the answers. Also development also we have because initially we are using that only we have asked the questions and they reply get the question answers. Okay, that type of AI only normally used. But nowadays, suppose I need to develop the particular source code means I will ask the questions and automatically AI will be develop the source code and particular applications. So that type of features newly added. So basic needs for the AI. So suppose we need to use particular artificial intelligence in particular concept. So basic dependency is there. So that means first one is we need to choose which concept. It's clear, right? Okay. So like a few basic concept is there. One is like based on machine learning concept. Next one is deep learning. That one is algorithm. So machine learning and deep learning, right? Suppose we need to use like particular image processing or real-time sensor data. We need to analyze with thousands of the thousand data of the values. We'll be using is the machine learning concept. So deep learning will be advanced with the machine learning concept. So deep learning means around we need to check the 10,000 data with minutes of seconds. We are going with the deep learning. Based on the dependency, it's like a Linux system and we need to use or so different type of computers we need to use the particular data. So next one is algorithm. So algorithm we have like different type of concept is there. So based on the application we need to use the algorithm. So normally algorithm based on that calculations and image processing, also like neural network. So based on the features, we are need to select the algorithm. So these are major three concepts for the AI. So based on the applications, algorithm is the heart of the AI actually. Okay. So which type of algorithm we are developing, based on that, its application be work accuracy. So upcoming on the like programming. So normally this all the concept working based on the programming is like Python language. So Python program language we need to use for the AI concept. So based on the AI, we working with the different tools for the development. So while developing the AI, we need to use like below tools. It's like a Google Colab for the compilation, and we need to predict the data for the train the data also. Next one Python IDE. Like while developing that program, we need to like compilation. This is a compilation tool for the Python program. Next one is like Linux platform, the environment. So we can use like different sub platform. So Linux OS is like best platform for that different applications. So for the AIs, so those are the basic needs of the AI. So those are the AI websites. Normally we are using like GPT. GPT mainly using with the like based on the prompt, like whichever prompt we are asking the question, right? So whichever is properly we set the questions, then we can that much of accurate answer we can get from the GPT. Okay, so that one. Next one, Gemini.google.com. So Gemini, uh, it's like another AI website. We can like develop the images also like suppose we need to also develop the image. I need to create the particular type of image with a different background. So that questions we can automatically develop that images. So also input also there. So based on that, give the our images is get the from the result. So Gemini, it's like another GPT similar of website. So next one is Google Colab. So Google Colab is like a normally we are using Linux operating system. We need to compile the code and we need to run the applications. So another one is like Google Colab. It's like a similar of operating system, Windows operating system concept. The Google Colab it's run from mail ID like a Gmail with a drive. We can all Gmail we have the particular account. We can easily access actually. So we need to develop the code and we need to train the algorithm, the GPT. So based on that, we can select on that. Next one, Jat OpenAI. So this one also like another website. We can get the data like how to like develop the music, particular songs or videos need to create. So that is our website. There is an application we can use for the based on the websites. Majorly, these 4 websites normally using that for the AI applications. So next one is like AI using BMS. So normally BMS system it is a separate and the AI is a separate. Okay. So this year we are collaborate with the AI with the BMS system. So upcoming slides we can see like a BMS system how operating with the based on the AI. So artificial intelligence why we are using which type of help we can get the accurate data. So that type of process we can get see here. So first one is like aim to indicate aim to investigate state of the effectively managing batteries in electric cars. So lithium-ion batteries used in the system because of the greater energy density compared of the other conventional battery. So normally we are using lithium battery. So how we can predict and how to so use it like use based on the AI. So that concept we are using here. The costliness of the battery electric vehicle offers significant opportunity for the engagement of the battery. So first one is SOH, it's like state of health. Next one is like SOC, state of charge. So prediction, we have the AI powered cloud service. So initially BMS system, right? BMS system normally based on sensors. Okay. Example. So real time means BMS when that be act. Example, particular battery is over voltage will be happen after the temperature value is increased. So while get the temperature value right. So that time sensor detected. That time we can get the notification. Okay, for running time. Well, car like electric vehicle is running. So that time temperature will be increased. So automatically we can get the sensor. We can get the identification in the same time. Okay, but while using the AI, right? AI it be automatically predict the before the time. Okay, so example battery voltage will be around 100%. Okay, we are running. So around 30% we have temperature value will be increased. Okay, but the battery percent around 50%. Remaining 20% is there. So before the time we can easily predict the data because while using AI, right? We have like particular cloud platform is there. So cloud is like a particular server. There is a storage actually. Okay. So normally inside of storage we have the previous data trained value is there. So also current real-time data we are sensor, right? So real-time data we are sending the particular cloud based on the API server. Okay. So that time AI will what happen? AI will be checking that previous data trained value to real-time data. So data comparing actually. So predict the data. So example 50% how much will be previously acted. That is a normal stage. But we are getting little more temperature will be to temperature value is increased means automatic detector. So then they automatically calculate the hours, how many peak hours happen means. So when we have the maximum temperature value we can get. So before that they will predict and we can inform the service data. So that type of help will be happen from the AI. So next one is like battery management system enabling the make the convenience, improvement, management choice, and neural network algorithm. So normally battery management system, right? So that one we are developing the CNN algorithm. So CNN or KNN algorithm. So NN means like neural network algorithm. It's like a Python scripts. Okay. So that basically we are developing the particular AI applications. So last point is a node, right? Example cloud-based server, right? We have like different of cloud services there, paid service. One is like everyone know like AWS. Okay. So normally AWS normally using like Amazon server. So another one is like so Node.js. Node.js is one type of developed platform, but these are they are like you need to pay the particular server particular years based on that. So after that we can use. So we have used like different type of apps, mobile application and internet support, also MQTT server. So in Node.js we have like different type of multiple web server and different application we can support. So mostly they take an AWS server or another one is like Node, this type of server we are using. So these are like AI data processing overview. So how AI is working, how we are AI developed. So that concept. So these are like a overview diagram for that how AI will be working at the model based. Example, initially first one is like data processing, right? So you can see like two types of data. One is like a real time data. It means like I means current, V means voltage, T means temperature. Okay. So electric vehicle. So current, battery, BMS, we can get the three sensors value: current, voltage, and temperature values. Next one is history of the data. It's like a around 1 year back, how much will be we are trained, right? So based on the IFO standard, right, we are get the particular reports for the data. Okay. So that data means like example 0% how much temperature will be there, 50% of the battery, how much temperature and voltage and current will be taken. So based on the battery pack, 80 volt, like 80 cells and 110 cells, also like 440 voltage range or 650 voltage range. So based on the battery pack, we have different type of data set is there. Okay, that is the data sets. So that is the history of the data. So data process means they checking the compare the value real time data to history. So data generation, right? So based on this comparison, they are developing this scenario. Like one is data collections, second one is data cleaning. Data cleaning means real time data to history, right? They are comparing and reduce the data. Like which one is like is properly under that one detecting. So data processing means so after that final result they are developed. Okay. So that is that final data processing, right? That data only we are monitoring from the in dashboard. So battery level percentage and how many kilometers we can take that one. So next one future engineering. So domain knowledge and machine learning. So that means while developing the process, right? So that time domain knowledge and machine learning. Machine learning means this particular algorithm, like which type of application we are using it. Similar of we need to use the particular machine learning algorithm. Domain knowledge means whichever data we are using, right? Data, train data. So that one example here, BMS means we are using like particular BMS system data pack. It's like a voltage, current, and temperature. This type of data trained data value, right, in the history. So that one. So next one is like artificial intelligence modeling. So that means this is the process actually. So it's like model training. Model training means they are comparing. So here different of application will be there. One is like machine learning, next one is supervised. After the classification, classification is like a comparison. Okay, so and get the result that one, and a regression and unsupervised and a reinforcement. So that means different features. So based on the application, we need to select. Normally we are using the classification only. So model selection, right? It's like a model training, validation, and fine tuning. So validation, right? Validation is a very important of the testing part. While checking the BMS system, we are cutting the validation for the value. Example, particular voltage ranging, right? So we are giving the how much charging time. Based on example 1 hour. So how much charge will be take? So battery temperature, how much will be take? So that have validation, we need to verify that. So these are different of states like battery states, also diagnostic information. Diagnostic information means so in battery in BMS side, any fault is there. So automatically diagnostic, there's a OBD actually, onboarding diagnostic. We can get the issue, like what is the issue happened, that one. Next one is thermal management. It's like a temperature value analyzing we are calculating actually, like normal mode and safety mode, unsafety mode, that concept. Next one is energy management. It's like which type of mode we are considering, the sport mode, normal eco mode. So how much battery voltage we are considering the voltage range. So that one. Next one is optimized information. So we can easily customize it also based on the different modes. So that type of modeling we are developed. So this is a data processing overview. So these are like overall black diagram, the cloud-based framework for battery management system in EV. So like this concept, three concepts are there. One is electric vehicle. So electric vehicle, here is a particular battery management system, DMS system, secure battery pack. Next one is like cloud-based framework. It's like a AI with cloud storage we are using. So first one is like battery pack. After that, like we are using a different scenario, data collections and thermal management and cell balancing. So that concept. So that part is we consider the BMS slave mode module. Okay. So based on the sensors, we get the data from the BMS slave. So also BMS main module is there. So main module is considered the get the data from here. Also like they are transfer the data. Okay. So here two different communication is there. One is like CAN network communication. So next one is a cloud-based communication. Okay. So here you can see like current, voltage, thermal, and pressure. So that are voltage like values we can get from the sensors for the real time. Also, time series data, field data, test data is there. Example in cloud, right? So cloud is like a particular storage also. Particular website we have stored the particular our values, sensing sensors values based on time period and how much time we take. So around 6 months or 1 week data we are storage will be there. So we can get the time series data, field data, and the test data also we can get for the sample. So like a state estimation, state protection, also emerge like energy management, optimization information. So all the data we can get here. So AI normally using the cloud platform here. So normally BMS is one side is there. They normally get the communication, but get the sensor value. It only predict the data. Cloud, so we can send the data and we are calculating and process the value and send data back again. That is like state estimation and state prediction. Okay. So these are management and control. So for the real-time value. So also common and technology for the cloud-based BMS system. So first one is like BMS normally using machine learning as a powerful instrument that algorithm normally using for the AI. Next one is like OBD, onboard diagnostic system. It's like a onboard battery management system with a cloud-based. Okay. So last one is a cloud BMS system. So normally, example, simple microcontroller means we need to use to flash the data, right? Particular application, we have compiled the code. After we need to flash the bin file, binary file or hexadecimal file. We need to upload. Okay. But in cloud platform means in BMS also particular ECU also there. Okay. Particular microcontroller, electronic control unit, particular microcontroller. We need to flash the particular firmware based on that features. It's like normally using the wire connection, right? Like serial connection or particular server or we need to use. But here OTP platform means particular server is there, particular IP address, particular so you need to upload the particular bin file in particular IP address, then automatically upload in anywhere. That is the OTA concept. So anywhere we can like upload the firmware concept. So that is the algorithm. Suppose any new features algorithm is updated, so that is a newly updated actually. So previously we can depend with a particular electric vehicle in service center. We need to go and we need to upload the software side or particular firmware side. Particular ECU is not working. We need to check the diagnostic also. But now all the features is come the cloud side. So we need to identify the data and any issue they happen. We can just we need to upload the mails and we can get the server. We need to get the particular ticket actually. So so no depends with the service center actually. So based on the EV vehicles, this is one feature newly added for the BMS side. So in advantage of the AI means like artificial intelligence and machine learning methods are increasingly being utilized to reveal the pattern of the inside of the expanding volume of the battery data. So while using like AI, it's like it's increasing the battery lives actually. Also like it's predict the battery issue. So now controlling the multiple accident on the battery plus in particular conditions. Also indicate the AI and machine learning is the BMS cloud based battery diagnostic. So that one we are using. So just I will show the basic overview of the AI. Like first one is the basic AI website. Next one is the machine learning concept, right? With the Google Colab. Last one is like Python programming for the sample applications. So how we are using the sample applications? So previously I mentioned the 4 website, right? One is like opening GPT. Okay. So GPT is like a open source. Just start open means you can get this one. You can ask any questions. It be automatically we can get the data. Example. Suppose we need to ask the question means they we can get the accurate data actually. So compared to normally we need to check the particular Google, okay, and we need to only show the different websites. We need to go the websites and a particular PDF document. So need to go, but here we can get all the data from the accurate value. What is the BMS system and why we are using? What is the difference? So that type of is there. Okay. So entire data we can get here. So this is one. This is GPT. Next one is Gemini. So this also here we need to ask like particular normal questions. Also like we need to add the image, give the input image. Okay. So upload the image and we need to ask. Otherwise like directly use the audio also. We need to give the instruction and they develop the particular source code also. Okay. So example, just I will give like so we can get the data. What is CN algorithm? Also we can get the program also. Okay. So now I just given that. So example, initially I give the like create the Python code for the CNN algorithm for the machine learning concept. Okay. So first they explain that what is the CNN algorithm. Okay. So convolutional neural network. Also like a key component of CNN. So here CNN that algorithm how we are using, what are the places we can use applications. Also, so they develop the Python code. Okay, for the sample code. So how we are giving the prompt, right? So prompt and like majorly like that communication and it's a prompt we are giving the input. So the input is the major part. Okay. So also we need to we can develop the particular image. We can give also like background image. So that are features we have already. Also video editing, like video editing, image edition. So we can use like different features actually. Okay. So this is the first one for the basic AI websites. Next one is machine learning concept, the Google Colab. So those are the different of algorithm. Okay, example KNN and linear regression, logistic regression maybe, and normally we are using like KNN and SVM for the detection. So K means and linear regression analysis LDA. So those type of algorithm mostly we are using. In Google Colab, right? So how we are using the Google Colab? So what is the Google Colab purpose? Actually, we are in Python code, right? Python program normally using like VS Code, Python IDE, also Google Colab. Okay. But what is the difference between Google Colab to different remaining things? Suppose we need to use Python IDE or a VS Code, right? So this is a VS Code, Visual Studio Code. Okay. So here I need to compile, or that one means we need to install all the libraries. Okay, those are the libraries. Okay, so while using Google Colab, no depends with the libraries. We can directly, no need to install, directly we can use. Go to Gmail Drive. After that, go to the new. So go to the mode, you can get this one. So Google Colab, this one. Because while training the data, right, in using AI, we have like a different data sets. Okay, so multiple data sets we have. So in our normal computer, we can't run that much of data. It will take very slow on that. So we need to use like Google Colab means this is an online virtual system concept. We can use like a particular value also. So change the running time also like. So you can see just the connection, right? So we'll change the Python 3. After that, the hardware like CPU and 24 GPU. That one also we can use like so multiple data we can means it be compilation and tracking now that have like more time. So we can use this one means it be have very fast. So I'm using GPU on that one and save the configuration. So now it's get the connected. So we can use here. So example, this is one code. Just here is giving like a Google Colab and from the drive. Okay. So example, initially my drives are particular different source code. Okay, in Gmail. So once you copy the code and directly you can run. So automatically we detect the particular data. Suppose any compilation error or be mounting now, we can so reflect it here actually. So it be asked for so connect the Google Drive. Suppose we are connecting Google Drive means it be asked the permission for the all the data. Okay. Suppose any error became getting here this step like message error and what is the error will be happen. So we can easily identify that. It's like similar of compilation only. So this type of code we can use. This is like a different classification. So those are the Python libraries actually. So while running, it automatically connect to the initial server. Okay. Because we are using multiple data means we can run here. So you can see once connection is done, we can get the data RAM and disk range, how much it will take. So here you can see RAM is like 12 GB. While running, it will be automatically updated. So this is a Google Colab compilation. While developing with a machine learning and deep learning concept, we need to use Google Colab for that process actually. So below the sample codes for the Python. So how will we can train? So these are different type of images actually. So how to find the different train the images? So next one is like Python programming sample application. So these are one sample application actually. So you can see here three data is the one is like data collection for the direct. This is one small project. I will show the hardware. So these are like a sample drone project. Okay. So in drone we have like particular lithium battery. We are using like three sensors. One is like LM35, voltage sensor. Next one is current sensor. It's connected with the so these are Raspberry Pi. So these are BMS system actually. So we need to use like particular data and we need to use the example Raspberry Pi or any microcontroller we can use. So just we can get the sensor data and we need to send the upload to the particular data from the server. So that is one main concept. So server I said that this is like so this is a node-RED server. It's we need to develop the server means we can get a similar kind of so this shape data. Okay. So this is like a non-IT, another one IT platform. So ERB, server, database, cloud, similar kind of we can use. Example cloud for platform we can use here. So I will say this is a like a paid website. I will show one sample for that free website. Okay. So these are things speak on free source cloud website. Okay. So just you can use your Gmail and you can log in it. So just application name we need to set. So just we can get the different type of data. Example here like field is 1, field 2, field 3 we mentioned, right? So it's like a sensor. Example 3 sensor we are using different type of sensors. We need to add the data. Example battery level. This is like sensor. Example voltage level sensor means we need to use field 1. So this is a temperature level checking. So that means be like a field 2. Okay, similar kind of we can easily modify that. How it be working? These are API keys. So server we have like two options. One is like a 2 keys. It's like a this is a URL. You can see right channel feed. This is one link. So this is like a status update receiving data. So normally while sending the data, right, that means we are using this link. Okay, we'll get the data, we can use this one status update on that status actually. So simple example initially you can see battery level is 80%. Okay, so 80% value is that. This is one API, just I'm change it to 60%. Okay, in battery level. So normally the sensor value, right? We are getting the data and we need to send the CAN network. We need to send the data to here. This value, this field 1, we need to update actually. So now get the data. So you can see here inside the website it will be updated. So you can see last entry less than the minute ago. So now this value is updated to 60. So while using like mobile application or a website, right, in dashboard, we can similar kind of cloud software we are using. Okay. This is one sample. So any question is there? So anyone, any questions?
Dear
Any doubt?
participants, if you have any questions, you can raise hand. You can hand raise if you have any doubts,
Raise or
please.
chat also, it's fine.
So far, no queries, sir.
Yeah, okay, ma'am. Okay, thank you, ma'am, for this opportunity. Thank you all.
Sir, thank you so much, sir. Really, I've given a very wonderful session on battery management systems and how to work with Google Colab also. Thank you so much. It was very useful for us.
Okay. Yeah, thank you, ma'am.
Thank you,
Thank
sir.
you.
Okay.
Yeah.
Dear participants, the feedback link has been posted on the chat window. Kindly don't forget to fill it. Then tomorrow, join at the same link at sharp 6 p.m. Thank you and good night.